Hello there, welcome to my first tutorial about the sound basics. In this tutorial we will discuss about the actual source of a sound engineer's inspiration, the sound itself and its basic principles. We will analyze all the basic principles of sound, and all the terms referred in these videos will be used in the next tutorials as well. So we have to make sure that we know for what we are talking about. So first of all, let's see how sound works. Every sound is a product of a medium that vibrates, and let's be clear on that. No vibration, no sound. As soon as the medium vibrates, it creates some acoustic energy, which in fact is changing the acoustic pressure. This energy will cause the particles next to the medium vibrate, and those particles will cause the next particles vibrate as well, transferring the energy. And this goes on until all the energy is fully absorbed by the particles. The particles absorb part of the energy as we feel the process of vibrating the next particle. So the energy transfer decays every time the action happens. Now we might presume that we're talking about air particles, as in most sound engineering cases, sound is traveling by air. However, sound can also travel via liquids and solid materials. And as a matter of fact, sound travels faster in thicker mediums, and that means that air is the worst medium for the sound to travel. So for us humans to perceive a sound is that those air particles reach our eardrum and vibrate against it. Just like the vibrating medium vibrates those air particles, it's the same way the particles vibrate against our eardrum. Our brain then analyzes those vibrations and translates them to the sound we actually hear. The closer we are to a sound source, the louder we perceive it, and that's actually because we are receiving a larger amount of acoustic pressure than if we were farther. That perception is actually called volume. Now, the sounds around us and how they sound are affected by three things. Firstly, the timbre, which is actually the initial character of the sound, and it's dependable to the physical properties of the sound source. Secondly, it's the environment itself, because it might actually alter the way the sound will reach its destination. And lastly, it's the ears of the listener. Yes, we all listen slightly different, as we don't have the same size of ears or the same design, and fortunately, that does not affect the hearing of different individuals in extreme level. The speed of sound is, well, variable, and that's because it actually depends on the temperature and the density of the medium that actually transfers the sound. So let's see a chart with the approximate speeds for different mediums. So we have 343 meters per second for air, 1482 meters per second for water, 3790 meters per second for wood, and for steel we have 5,960 meters per second. So what's the easiest formula to calculate the speed of sound, and of course the one that interests us, sound engineers? By looking at the following formula, we can see that V equals 331.4 plus 0.6 Tc meters per second. In this equation, V is the velocity of the sound, or else speed, measured by meters per second. 331.4 is the speed of sound at 0 degree Celsius. For every 1 degree Celsius, we add 0.6 meters per second to that speed. Earlier we mentioned that the speed of sound for air is 343 meters per second, and that doesn't match the value in the previous equation. That's because when we are referring to the 343 meters per second for air, we count it as if it was in normal environmental conditions. That means about 20 degree Celsius. So do the math using the equation to see if that actually matches the 20 degrees, and I will see you in the next tutorial talking about sound waves.